Alright, welcome to Unit 4. This is our first video, and we are talking about endothermic and exothermic processes. So, we're starting a unit on thermodynamics, and thermodynamics is the branch of chemistry that studies the transfer of energy in reactions. Now, energy we're going to define as the capacity to do work. But there's two main forms of it, kinetic and potential. Now, thermodynamics, if you were to look at this basic match, would deal with how much energy that heat is producing, how fast it is burning, how much water fuel it can heat up. That is what thermodynamics will study. Now, back to energy. We have two types, potential and kinetic. Potential energy is stored energy, and this occurs due to the object's position or sometimes configuration. Think of the spring. It's pushing up really hard on this guy's hand because basically of how it's coiled. That is an example of potential energy. Kinetic energy, however, is energy associated with movement. Basically, anything that moves has kinetic energy. For example, the soccer ball. If it were to hit you, it would actually bump off. If hit hard enough, it may even hurt. That is kinetic energy. It's energy associated with the soccer ball moving. Now, in chemistry, we're going to focus on kinetic energy. But before we actually do much with that, we need to define two terms, system and surroundings. Now, the system is the part of our reaction that we are interested in, and everything else is called the surroundings. Together, they're called the universe. So let's look at this cup of ice, water. The system, if we were dealing with a reaction of the ice and water melting, would likely be the water and the ice. And the surrounding is everything else affecting that cup, which is air or your hand if it's touching it. Typically, system's going to be whatever they've mentioned in the problem, whatever you're interested in looking at. Surroundings are whatever's, affecting it. In thermodynamics, we deal with energy being transferred. So we have two types of processes, endothermic and exothermic. A process in which energy flows into the system or in which energy is absorbed by the system is called an endothermic process. Any process in which energy flows out of the system or in which energy is released is an exothermic. Now, way to kind of help you with this is therm refers to energy or heat. Endo refers to going in, and exo refers to going out. So endothermic is heat coming in. Exothermic is heat coming out. Now, something of heat coming in would be a cold pack. It takes the heat from you, and thus you feel cold. Exothermic is something that produces this heat, like thermite. It will get very hot and will provide a lot of energy to really whatever it's touching. And back to system and surroundings. If you were holding the cold pack, the system would pretty much be the cold pack. Surroundings could be considered your hands. So the energy is going into the cold pack. And this reaction of thermite could be the system, and the air is the surroundings. The energy is leaving the thermite and going into the air. All right. Now, the law of conservation of energy, hopefully you've heard this, states that in any chemical or physical process, energy is neither created nor destroyed. The total energy of the universe remains unchanged. Now, if we look at Albert Einstein's work, this gets a little bit more complicated, and we'll talk about that later. For now, though, feel free to be satisfied with this definition. You may hear differences from other people. But let's look at this. Endothermic says that heat comes into the system. Well, you're basically saying that I've taken a little blob of heat and moved them in. The heat hasn't changed. It hasn't gone anywhere. The heat's just inside it instead of outside. Vice versa. Exothermic says take this out. The heat doesn't change. It doesn't magically shrink or grow. The total energy stays the same. That's what the law of conservation of energy is talking about. Now, let's get an example. A container of melted wax stands at room temperature. What is the direction of heat flow as the liquid wax solidifies? And is the process endothermic or exothermic? Now, this is about the best picture I could actually find online that shows you some melted wax and what happens when wax hardens. Now, as melted wax basically occurs when wax is very hot, so as it cools down, it typically solidifies. Now let's think about this. If something's cooling down, we've got wax. If something is cooling down, that means it's losing energy, it's getting colder. That means, from the wax's perspective, energy is leaving. If energy is leaving, that means it's exothermic, which means that as it cools down, it's losing energy, and eventually will lose enough that it won't be able to stay a liquid and will eventually stay as a solid. So the heat is leaving the wax and thus exothermic. That is our example. Here are some practice that you can use during the classroom. If you're watching this at home, I recommend trying it. But list 3 processes in real life that are endothermic and 3 that are exothermic. Then for 2 of those, identify the system and surroundings. Good luck, and thank you for watching.